math discovered or invented? There are two schools of thoughts. One is called mathematical realism, while the other is called mathematical formalism. Mathematical realism starts off by seeing something that occurs in the real world. For instance, you can count. So numbers such as 1, 2, 3, 4, 5 comes out. Slowly, the number 0 develop, and negative numbers at a later date. So from integers, they start to move on. After integers, mathematicians found out that numbers can be divided. Thus, rational numbers comes out. For rational numbers, there is a small activity that you need to try out first before you continue this video. So pause this video, perform the activity. Go on. So why do rational numbers have repeated decimals or recurring decimals? To understand this, we need to perform long division so that we can see it clearer. If you remember from your primary school years, when you perform long division, there will be remainders that you need to bring down. Let's take this particular instance. I'm taking 1 divided by 7. If I'm doing this, my possible remainders would be 0, 1, 2, 3, 4, 5, 6. That's all. If it's 0, then the number should terminate. But if it's 1, 2, 3, 4, 5, 6, then we will carry on dividing and dividing. Alright, so the thing is, if you were to do this, there's only a limited number of possible remainders. So there will be a point in time whereby our remainders will repeat itself, and thus making the quotient repeat itself. So what do I mean by this? Let's take this particular instance. I'm taking 1 divided by 7. My first remainder is 3, followed by 2, 6, 4, 5. I kind of exhausted all the possible remainders, and then I get back to 1, which is this. So, intuitively, my next remainder should be 3, which is correct. 1 and then 3, 1 and then 3. So, my remainder will repeat. If my remainder repeats, then my quotient should repeat. So it is 0.142857, 142,857, 142,857. So we have proven why rational numbers have repeated decimals or recurring decimals. Rational numbers done. Are we done? No. Mathematicians found out that there are numbers that do not have recurring decimals or repeated decimals. So these numbers are not rational numbers. These numbers includes pi and square root of 2. If you want to know how to prove square root of 2 is irrational, you can refer to my math shower video. But the thing is, the pattern keeps continuing. From integers, they move on to rational numbers, then irrational numbers, and later on, they came up with complex numbers. So this is what we call a mathematical realism point of view, where they construct math from something that already existed, and then they move on to come up to where they are right now. That is mathematical realism. Another view is actually called mathematical formalism. Right? How this works is that it works on a set of axioms, a set of rules that is meant to be true or accepted to be true without any form of proof. From the axioms, they come up with theorems. Do bear in mind that this set of theorems need not have to bear any significance to the real world. It is just a set of rules that works only on the basis of the system itself. It needs to be consistent within the system. It's kind of like the game of chess. The game of chess, when you play it, there are a set of rules. Those rules only apply to the game of chess. Anything outside the game of chess, the rules bears no meaning. So this is another view which is called mathematical formalism. And those are the two schools of thoughts: mathematical realism, mathematical formalism. If you think about it, mathematical realism, since it works on the basis of seeing something from the real world, you can say that math is discovered. Okay, it is discovered that 1, 2, 3, 4, 5 applies to this. It is discovered that numbers can be divided. It is discovered that sometimes numbers can be irrational, or moving on to complex numbers. But if you look at formalism, mathematical formalism, okay, then math is actually invented. Okay, we create a certain set of rules that only applies to that particular system as long as it's consistent. Right? So let's go back to the question: is math discovered or invented? What's your take on that? That's all from me. Let's talk about math.